Hello and welcome to another video on the solar system. So today we are going to be talking about the properties of the inner planets, and then we will go on to the outer planets. So the first planet closest to the sun is Mercury, also the smallest planet in our solar system, and it's only slightly larger than Earth's moon. Mercury is the fastest planet, zipping around the sun every 88 Earth days. Although Mercury is not the hottest planet in our solar system, because the planet is so close to the sun, day temperatures can reach highs of 800 degrees Fahrenheit. Could you imagine that? We would not survive as humans in that. Without an atmosphere to retain that heat at night, temperatures can dip as low as negative 290 degrees Fahrenheit. Again, would not survive. You would get hypothermia probably within a matter of a second. Mercury's axis of rotation is tilted just 2 degrees with respect to the plane of its orbit around the Sun. That means it spins nearly perfectly upright, and so does not experience seasons as many other planets do. Mercury's surface resembles that of Earth's moon, scarred by many impact craters resulting from collisions with meteoroids and comets. Craters and features on Mercury are named after famous deceased artists, musicians, or authors, including children's author Dr. Seuss. So there's actually a crater out there on Mercury named Dr. Seuss. So that is a fun fact. Now you know that there is a crater on Mercury named Dr. Seuss. And dance pioneer Alvin Ailey. So, 2 craters on Mercury. Interesting names. Next, Mercury is the second densest planet of our solar system. So if you have studied physics and chemistry, you know what density is. It's not necessarily weight. It's it has proportion elements into account. In other words, it factors in weight. Is it the heaviest planet? No. But it is the second densest planet of our solar system with a large metallic core, and the color is grayish brown to the human eye. So next we have Venus. Venus is the second planet from the sun and our closest planetary neighbor. It's the hottest planet in our solar system and is sometimes called Earth's twin. Venus is the third brightest object in the sky after the sun and moon. Venus spins slowly in the opposite direction from most planets. Venus is similar in structure and size to Earth, and its thick atmosphere traps heat in a runaway greenhouse effect, making it the hottest planet in our solar system with surface temperatures hot enough to melt lead. Below the dense, persistent clouds, the surface has volcanoes and deformed mountains. Because of the planet's extremely slow rotation, sunrise to sunset would take 117 Earth days. And by the way, the sun would rise in the west and set in the east because Venus spins backward compared to Earth. So let's think about this for a moment. Would you want to be stuck on Venus if you could? 117 Earth days. Sunrise to sunset. If you look at it in a positive light, if the sun was out and it took 117 Earth days for the sun to go down, would you be happy? For me, I need my REM sleep. So no, I might not enjoy that slow rotation of Venus as well. It being the hottest planet, we wouldn't even survive anyway. But I wanted to put some fun into this because these facts can be monotonous. So, point to bring home with Venus. It's the hottest planet in our solar system, okay? And its thick atmosphere is trapping in that heat. Its surface, so below the clouds, the surface, it has volcanoes, mountains, and it's a very slow rotation. Okay, so coming right after Venus is Earth. Here we are on Earth. Earth, our home planet, is the third planet from the sun and the 5th largest planet. It's the only place we know of inhabited by living things. The inner core of the Earth is a solid sphere made of iron and nickel metals about 759 miles in radius. Surrounding the inner core is the outer core. This layer is about 1,400 miles thick, made of iron and nickel fluids. In between the outer core and crust is the mantle, the thickest layer. This hot, vicious mixture of molten rock is about 1,800 miles thick and has the consistency of caramel. The outermost layer, Earth's crust, goes about 19 miles deep on average on land. The surface of Earth is made up of Earth's lithosphere, which includes the crust, both continental and oceanic, in the upper mantle, and is divided into huge plates that are constantly moving. So if you learned about tectonic plates, you know that when they converge, they can form volcanoes, landforms, mountains, etc. Earth's atmosphere is 78% nitrogen, 21% oxygen, and 1% ingredients. Could we say, yes, there is some air pollution? We have so many carbon dioxide emissions, but essentially what matters is Earth is the only planet with life. We live here. We can breathe because of the atmosphere of Earth. It is not too hot, it is not too cold, and this we can live on its surface. Also, I did not include in this lecture here that the Earth is 71% water. The majority of Earth is water and not land. And there are some waters that have not been discovered. Although we have so many bodies of water, there have been so many land discoveries, there is still more to discover. Okay, so I think that was everything for Earth. Go to the next slide for the inner planets. We have Mars. Hey, Mars. Mars, the fourth planet from the Sun, is a dusty, cold desert world with a very thin atmosphere. This dynamic planet has seasons, polar ice caps, extinct volcanoes, canyons, and weather. As Mars orbits the Sun, it completes one rotation every 24.6 hours, which is very similar to one day on Earth. Martian days are called sols, short for solar day. A year on Mars lasts 669.6 sols, which is the same as 687 Earth days. Mars's axis of rotation is tilted 25 degrees with respect to the plane of its orbit around the Sun. This is another similarity with Earth, which has an axial tilt of 23.4 degrees. Like Earth, Mars has distinct seasons, but they last longer than seasons here on Earth since Mars takes longer to orbit the Sun because it's farther away. Mars has two small moons, Phobos and Deimos, that may be captured asteroids. Maybe. They're potato-shaped because they have too little mass for gravity to make them spherical. Mars has a reddish color, also known as the red planet, because the Martian dirt oxidizes, giving it its rust color. So as you can see, look at that planet. I love that color. So Mars, I love that rust color. But again, it's an oxidation process. So it wasn't just, okay, poof, out of nowhere, it decided to make itself orange. You know, like a human, we can put on makeup, make ourselves face paint orange. No, there was an oxidation process. Mars has its rust color due to this process. Thus, it's called again the red planet. Okay, so I think actually, yep, there we go. We are done with the properties of the inner planets. Now I want to go on to the next slide. Okay, we will do that on the next video because I don't think it's letting me switch sides. So let me just stop that for now. Okay.